Hello, everybody. My name is Brian Miretta. I'll be chairing this session. I hope you all had a nice lunch. Hope you had coffee and you're ready for the next presentation, for the first presentation of this session. Let me introduce Vlatko Kosturjak to present something we all know. It's always DNS. Vlatko, the floor is yours.
Thank you. Hi. In short, thanks for having me here. I will talk about the vulnerability I discovered some time ago, actually late last year, but it got disclosed early this year, and it's about, DNS. If you're asking if I change the company, no, we just got acquired, so it happens. Since this is my first RIPE event, I thought some proper introduction should be there. So I'm doing cybersecurity for more than 20 years. I have experience even with this acquirement, a lot of M&As as well. I have contributed to many open source projects, popular ones, and even those which are not so popular, and authored our own, let's say, my own ones. Anybody used Nmap, like network mapper? Raise your hand. Okay, so you know it, right? So that's one of the things I contributed in the past. So probably if you were running Nmap, that probably used some of my code there. This is from some of the developers dinner we had in the past. Also, I guess you know, for Metasploit, that's another project I was working on. Also contributed code there. I also contributed to OpenVAS. Now it's Greenbone mostly, which is famous, let's say, open source vulnerability scanner. So these are all the things I contributed so far in the open source as well. Since now you know me, now it's time that we talk what I'm going to talk, how we will spend next 30 minutes. And we're going to talk and answer on the question what the drones have with DNS. I think that's one of the interesting things and facts. We will all go through those, vulnerabilities and so on, what happened and how it came to that point. But yeah, let's start. How it all started, I guess when you start your weekend, probably you want to go with your family, get away weekend, go out from the town. Some, let's say, very common, in my case, is I was testing some of new stuff which I made out. So what I tried to do this time is I automated most of my workflow for vulnerability discovery. So I said, guys, give me some, things to see how it's working. And one of the wish lists was actually Bind. And he actually sent me the link and said, try it out. So yeah, challenge accepted, right? It's not the easy target. For someone who don't know what is Bind, but I guess we are at RIPE, so I guess you know what is Bind, right? That's the most popular DNS server. And DNS server is used actually to translate the IP addresses, actually DNS names into IP addresses, and also vice versa as well. So I don't want to spend too much time on this one, because probably you know what it is. And yeah, the first thing I asked always myself is what everybody is doing, what I should do differently to actually find something new, right? In this case, I wanted to see what currently the guys are fuzzing. Let's look what the Google is fuzzing and so on, and let's see what I can do differently. Also, other question which I usually ask is, what is there new stuff? DNS as a protocol, it's also gets development and get some updates and so on. So it's always good to actually look what's the new stuff there. And of course, let's look in the past what others have done. So I actually found out they introduced something called, breed and age hit thing. Actually, what they come up is they wanted to identify the drones. So when the drone is coming, they should broadcast some kind of information. But how you can actually, say that this drone is sending the right information, what it should be, and also that this identification, it goes as it should be. So there's two questions asked. One is this drone broadcasting the right info? And is this drone legit, right? Is it really broadcasting what it should be? And actually they was thinking what kind of, directory we can use. And they said, okay, why not? Well, let's just use DNS for this part. So they can just introduce new DNS record types. And there is a, IETF standard for DRIP. It's actually this thing, how you can actually identify the drone. So this is the thing, how you can actually connect the drone and the drone field with the DNS. And this really got interested because nobody else so far played with this one. So of course, my time is actually to play with this one. So how it looks like this kind of requests. This is typical zone file. And you will actually notice that it's some kind of ASN1. They use some kind of a crypto so you can verify that it's really signed and that the data is right and so on. So it's very similar to this one. So you can actually, get already the idea what can actually be problematic. ASN1 usually parsing can have memory corruption problems and so on. And of course, what I have done, try to do all the combinations. Usually you use some kind of a fuzzer to actually, once you know all these things, you actually try to run all the combinations, fuzz it, right? And I came to the point where you can actually crash the bind. How? Actually specifying these records, but that they are small ones, not the big ones. That's an interesting part. So as you can see, these are actually two records. One is for breed and one is for age hit. They both can actually crash some earlier versions of bind. And loading the zone file is not so interesting, right? You can actually, crash yourself. So it's not so interesting, right? If you look at the source code, the problematic part here is actually this require. It's actually assert, which tells you, okay, just bail out, exit from the DNS server completely if the length of the packet is smaller than 3 octets. So they done it on purpose to actually, usually when you have asserts, you don't want to get into some state which is not good, usually to prevent some kind of a memory corruptions. But in this case, it's actually working against it. But of course, this is actually local. There's no real impact. And you have an idea how we can maximize this impact, because loading the zone files usually do it from the local file system, and that's it, right? Any idea how we can maximize the impact? Okay. There's no hands. So finding maximal impact is actually, trying to load such zone file over the network. And there are a few things how you can do it. One is, of course, defining, primary DNS server. And then that somebody else do the zone transfer and so much. But this is the problematic part because you cannot do it, Somebody have to request for this DNS zone transfer. And sometimes, it's not so impactful, let's call it, because something you rely that someone else will ask for this zone. And it's not so, there's no big impact. Another thing is actually to do something else. Why not have your own DNS zone, right? And then just asking for it. That's much better, right? In this case, you can actually serve this, let's say, very illegal crafted zone file. And then you can just ask each DNS, hey, give me this zone file. And then once this zone transfer happens, right, the bind crashes. So that's the actual idea how you can maximize the impact in this case. So to illustrate this example, is actually you create something like zone file which is carefully crafted so to cause the crash. you actually ask for this zone file. Actually, you just make a DNS request. And then you can see in the logs that bind is actually done the assertion. And that means not serving DNS requests anymore. So yeah, this is the plain and easy, I will call it, right? So another interesting fact, from the wish list to the first crash, as you can see, there is a little bit more than 4 hours. That's something where GenAI helped me. With what? First, identifying what's new. The second, writing harnesses. So I could really optimize my workflow to find these bugs much faster than I could before. And also to write reports as well. So this is kind of, let's say, the part I could not do it faster before. Of course, the submission process. Okay, of course, I then spent all night. That night, it was like 9 when the first crash was to actually confirm it to different versions. And then I submitted it in the morning just to sleep over and see if it's really working, right? If I did not do, because of lack of sleep. And yeah, the process is straightforward. You just go there and submit. But one interesting question caught my eyebrow is, what I would expect usually from intelligence agencies is, have you shared this information with someone else? So one of the interesting questions. But yeah, once you, write this everything, you expect, that it will get fixed, right? So everything went good. Tomorrow morning, Saturday, non-working day, I sent like 7:53. And actually, I got immediately like automatic email. Yeah, we received it, so good. At least the email went well. But yeah, they will respond as soon as they can. But okay, and that's great. But that's automatic ones. Let's see what they will see once they, look at it up. And the first thing is, oh, I don't see the way how this can be triggered remotely. The problem I explained you much earlier, right? I actually send them just the zone file and the reproduction, how they can do it locally. Why? Because they can reproduce it faster. And the other thing is, they can think, probably the authors of the software, they can probably think much more ways how this can end up in the zone, not just maybe by recursive resolver, maybe something else like a secondary and so on. So probably there is much other way. So I told them, look yourself, you are better than me, right? In finding all these paths. And yeah, the problem here is, he said, look, I don't see this is a bug. Let's just, it's just to annoy yourself. So this is actually the turning point. Right, I could say, yeah, that's right. And we could have this bug for some time as well, right? And nobody will notice it. But yeah, I think again, and I said, okay, I will send you another exploit, which is like a proof of concept, but from the network, just to demonstrate this maximal impact which I showed you. And yeah, let me show you, send him, okay. I just removed the names, just that doesn't expose anyone. I said, okay, here is, this exploit over the network, please look it now. And let me know. And now the silence. So that can mean two things. Maybe I'm blocked, right? The second thing is probably, well, maybe they are doing the triaging, so that's maybe good. So after a few days, oh yeah, same as me, right? Working night. Yeah, he was also working night. He didn't look too much. So yeah, they confirmed it. But it was, some time it took, and I didn't know what's happening. There's the problem with, this transparency thing where you don't know what's happening behind. And yeah. But the problem, yeah, I have colleagues which said, hey, it's a denial of service. It's not a, remote code execution. You cannot execute the code on the DNS server. Yeah, I know. But the the problem, yeah, it still reaches a cert. And actually, bind is really planted everywhere, those asserts, actually to prevent those memory corruptions, but at the cost of the crash. So that means every memory corruption, in most cases, you will hit the assert, which is good because nobody can execute the code from the remote point of view. But on the other hand, you reach the crash. But in case of DNS, even that one can cause really bad problems. You know, everybody, you're administering the networks and DNS stuff, so you know how it works, how it looks like when DNS doesn't work, right? So it doesn't serve any DNS requests. Even when you browse, check your email or whatever, you cannot, right? And most of those things which are on top, it just doesn't work. So yeah, impact is high. And yeah, many services are dependent on DNS. So the problem is really you can turn off internet for many, instances. In that case, of course, real men use IP addresses or MAC addresses, right? Depends how hardcore you are. Why it's also a success? Because bind is being fuzzed by Google, I mean, every day, right? It's part of the OSS fuzz project. It's being inspected by many legends like this guy, I guess you know who is this one, Dan Kaminsky, who unfortunately is not with us anymore, but he's really inspiration for many of us. And if you look from the point of view, how many, CVEs or the bugs bind have, it's actually only 3 of them. I mean, more than 3, but usually who actually reported them is usually, researchers who are doing in teams and from many universities. And from the countries which usually, invest a lot into cybersecurity, like Chinese and Israelis. And you also have, these projects like Google Big Sleep and so on. And this is actually being done by a single person. So that's kind of a difference in this one. Another thing is, which I would like to let you know that actually I reported vulnerability on 1st of November. This acknowledgement came 3 days later. But then all the fix and everything actually took like 2 months. If you see, that's a kind of asymmetry, right? You see this little point here, it's here, and the rest is really only fixing. So I think we can do a better job, in squeezing this window a lot. And also then, again, you have also the part where you have to implement it on your systems, where it should be also lower. So yeah. So I even followed good practice to actually publish the exploit or proof of concept code later than the vulnerability was disclosed. So everybody have time to patch before, script kiddies come and try to crash someone. So we also delayed that one to actually not cause havoc on the internet. Now, of course, there's a question, is only bind affected? Well, the problem is, yes, but the problem is that many other DNS servers does not implement this drone standard yet. So probably they could be affected in the future. We haven't seen their implementation yet. So yeah, currently only bind supports this drone identification, and that's why they are vulnerable, but they are fixed it right now. And of course, there's many other appliances which could have bind embedded. There's a lot of appliances who had such embedded, IC bind in their appliances, and you have to check, each case by case basis if this can be affected by them as well. But another thing which is also interesting is now drone security products, because they need to look at the drones, get this data, and then process it. And this can also be the point where you can actually crash them or execute malicious code if they are not doing it right. So that's another point of view or perspective what else can be effective against them as well. And yeah, I published later this proof of concept. I delayed really more than a month, but the question remains. You know, there's a lot of things with Gen AI what we need to rethink about. So this, for example, delaying of exploits for a later date. I know, for example, there was a lot of complaints in the past where exploit and the vulnerability was disclosed at the same date, so it caused some problems. But now with Gen AI and all these things, I think this does not make sense. So just to prove my point is, you know, this is, I just wrote create proof of concept exploit for this CVE, which is this one for the bind. I gave him only like a vulnerable version of the bind and also non-vulnerable version and told him just create me the exploit. And actually it took some time because of recompiling and everything. And because, you know, I just used Claude Code, which anybody can have access to. Actually, I just had guardrails removed. And, you know, in more than a little bit, 4 minutes, I got the exploit code. So I think we really need to rethink this part of the story. Do we have to, you know, delay this one when anybody can do it? Maybe not with the Claude Code because you have this cyber verification program, but anybody can take then, for example, local model, take a heretic to remove the guardrails and do these things. So I don't see this actually helps currently. So it's more like security theater than helping in these things. So as you can see, 4 minutes, which took some time for my typing, but actually all the things he done is actually cooked for 3 minutes and 36 seconds, and you have it, right? So yeah. And how to fix it? Actually, fix is easy. You just need to, you know, upgrade, and that's it. You do the apt-get upgrade, or I don't know, whatever distribution you use, and that's it. The problem is, even if you don't use this feature of the drones, you are still vulnerable because there's no way you can turn it off. So the only way to actually be safe from this one is to actually have, you know, upgraded versions, and that's it. Yeah. And yeah, of course, then the media, you know, joined one and one. So they said, oh yeah, this is actually vulnerability where you can actually crash a lot of things. And also, you know, local media and so on. Yeah, so it's too much. But also, what I want to tell you is that, you know, we find a lot of those vulnerabilities and we publish them on a regular basis. So you can always check out which ones we found. One of the interesting things is, for example, if you used, for example, WHOIS, they have a lot of, you know, those things which are, they like, you know, to statically embed some credentials and then anybody can use it, right? Do not call it some other way. And yeah, what the lessons learned? Well, depending on your role. If you're a programmer, asserts are a really good one to prevent, you know, even more bad things. So memory, like memory corruption or code execution later. Usual cost is crash of that one. But if you're a system architect or administrator, I think the biggest takeaway is that you should have like a, you know, secondary DNS, but not the same product. Because if you have two binds and there is a problem with one, you have the problem. It's usually easier to actually administer two same servers, but then you risk of having it downtime, and this doesn't work, then most of the DNS and all the services up does not work. So it makes sense to actually have two different vendors for a DNS server. And of course, as you can see, keeping functionalities to minimum. If you could turn off this drone thing, you could actually do it, but from the vendor point of view, you couldn't, you know, turn it off. So you're vulnerable. And yeah, updating software is, as you can see, valuable in avoiding such problems. And if you're a zero-day hunter, yeah, I would say there's a lot of people who are afraid of OSS fuzz, but usually what's the problem is they don't cover complete, project's inputs into the program, so you can actually do differently, as I showed. And they are still using the old fuzzer. The coverage, which I mentioned, is not so good, but it's still good one to have it. And the maintenance of complete, harnesses and everything, there's a lot of projects which are working at one point, and then the project got updated, but the harness is not, and then it's not working, and so on. So these are all the things which I think can be also improved with the Gen AI, not just this, part for the offensive part. So in short, summary, as you can see, even highly, checked projects, DNS, it's being looked at many times, can be no problem. It still can have problems because it also gets updated over the time, and the future is being added, and we are all, as you can see, still dependent on DNS. And during all this process, nobody, we didn't see exploitation in the wild, so that means the hackers can keep secret. For me personally, that means that I count this as a 30% of internet being hacked. So for me, it's time to hack the other 2/3. So let's see. And yeah, that's it. Any questions? These are my contacts. If you want to question it later, you can use direct messages, or if you're shy, I'll be here during the sessions. So,
any questions for Vlatko, maybe? No? Everything clear?
Well,
yeah. So Vlatko will be here in the pause after the presentation. So feel free to contact him, and that's more or less it, I would say. Yeah.
Okay,
Thank you, Vlatko.
Thanks for having me.
Next up, we have Ulrich Wisser talking about zombies and Walking Dead protocols. The floor is yours.
Hello? Okay, good. Yes, hello, I'm Ulrich. Yes, the Walking Dead protocol, WHOIS, well, it's already dead, it just doesn't know it yet. So, and let's see why that is. Green button? Yes. So first a little word about the organization I work for, ICANN. I hope all of you know ICANN, but if not, let's just go through this. We are the Internet Corporation for Assigned Names and Numbers. And if you don't know us, you don't know us now either, because it doesn't tell you anything. But what we do is we take care of the unique identifier system of the Internet. IANA is a function of ICANN. So if you get your IP addresses from RIPE, RIPE gets its IP addresses from IANA, from ICANN. Okay? And we take care of the root zone for the DNS. So the top-level domains have to contact IANA to make changes for the top-level domains. And then we have this, what is called protocol parameters. And if you think of, for example, just we heard this, the type 68 and 67 in DNS, that's a protocol parameter. And we have a registry where we write down what that 67 and 68 means. That's the protocol parameters, okay? So that's functions of ICANN. So WHOIS is a really, really old protocol. It's, it's from the beginning of the internet, basically. Okay, and it has been available for a very long time. It's used by almost all CCTLDs, all GTLDs. It's used for, for all the IRs, and and it's used to, for identifiers and to see who is responsible for them. So in the beginning, it was like the idea, well, if there's something wrong with the domain name, then I can use WHOIS to get a contact information, and I can tell these people what's wrong with their domain name, or what's wrong with their, if they have a routing error, I can look up the IP addresses, and then I can contact the administrator of the network and tell him what's wrong with his routing. Okay? The internet grew a lot, And then a lot of other people thought they had other uses for the WHOIS data. And yes, so nowadays there's a lot of questions about who gets access to this data, and then we have GDPR, of course, and then not so many people get access anymore. But well, to call WHOIS a protocol is like an exaggeration. Okay, what WHOIS basically is you open a TCP connection, you send one identifier, and then whatever you get back, you display to the user. Okay, there's no content moderation. There's nothing. You can't tell them there's another language, another encoding or anything. It is just pure. I send you something, and if you understand it, you send me something back. Okay. So and of course there is no security at all. So well, there has been numerous tries to make other protocols. We have RWHOIS, WHOIS++, IRIS, WEIRDS. They didn't go anywhere. And then the IETF actually made a new standard, RDAP, the Registry Data Access Protocol. Yeah? And in 2017, the Registry Support Group, something? An ICANN group at least, and the registrar group. The registries and the registrars agreed on that we should switch over to RDAP. Then, of course, it's not only so easy to switch over, so what they said is, well, we all should do RDAP. Okay, so and in 2019, ICANN actually decided that all the generic top-level domains have to implement RDAP, okay? And why only the generic top-level domains? Because these are the top-level domains that have a contract with ICANN. The country code top-level domains are independent. They can do whatever they want. If they want to implement RDAP, they do it. If they don't want to do it, they don't do it. Okay? And same goes actually for the RIRs. They're also independent. They do whatever they want. But all the RIRs have implemented RDAP. So, why I'm here on stage? Because since last January, actually, WHOIS became optional for the generic top-level domains. So they have to have an RDAP server, but they don't have to have a WHOIS server anymore. Okay, and well, a lot of them don't have one anymore. So we have that's the the amount of top-level domains varies in the root varies a little bit from time to time, but you see there's a distinct amount of top-level domains that don't have a WHOIS server, and there's a larger amount of top-level domains that have an RDAP server. And so what is RDAP? Well, it's a standard from the IETF, and then there is an implementation profile for the GTLDs that they obviously have to follow because they have a contract with us. And so the standard gives the technical specifications, and then the implementation details give some policy, what has to be shown, what doesn't have to be shown, and so on. So, and yes, and so what RDAP does, it supports internationalization. You can actually put in information in different languages. So if you think of, if you write in a different script, you might want to have a set of information in Latin script, in English, and then in whatever script you use natively in your country. We have transport security. It's a REST-based protocol, so it's run over HTTPS. Structured queries. The queries are JSON. The answers are JSON. And one of the very important things is that authoritative servers, and obviously WHOIS has that too, but in WHOIS there's no way of knowing which server is responsible for which top-level domain. You just have to know. And so if you have a WHOIS client on your machines here, and you just say, oh, but I just type in WHOIS, domain name something, and it works. Yeah, that's because the maintainer of that software puts in a lot of work to get the correct server addresses for the WHOIS servers. But you don't have to do that for RDAP. RDAP has a bootstrap method. So IANA has a list of the authoritative RDAP servers for all the top-level domains. And as a client, you can just get that list, and then you don't have to guess, and no maintainer has to, run around and guess what servers it is. There is an authoritative list of servers, and you can use it. And last but not least, RDAP protocol is extensible. Yeah, so yes. So one of the things that I just talked about the bootstrapping, but we have this HTTP redirects. So because it's HTTP, we can just redirect to other servers. For example, if you think of IP addresses, you would get a request for IP address, you can send them to the IANA RDAP server, but then IANA will say, well, we have given these IP addresses to RIPE, so we redirect you to the RIPE RDAP server because they will have the correct information. So things like that. Referrals, it's quite important if you think of top-level domains. In most country code top-level domains work like they have what we call a thick registry. So the country code top-level domain has they have a database with all the registrants. They know the people who have registered the domain name. But a lot of generic top-level domains have what we call a thin registry. They don't have the registrant information. Only the registrar has that. So the registry only has information about the name servers and maybe some IP addresses, what is just needed for the DNS, but they don't have any other information, registrants and whatever, So when you make an RDAP request for these domain names, you will actually get a referral and say, well, if you ask for this domain name, we can give you this little information, but here is the address of the registrar RDAP server, and the registrar has all this other information for you. So, so a usual flow for RDAP looks like you get the bootstrap file from IANA, then you find the server for .org, and you send the request to the .org RDAP server. You get the result, it refers you to the registrar for the domain name, and then you can get the real registrant information from the registrar. That's how can look up who registered ICANN.org. I guess it was us, Okay, so RDAP not only works for domain names, it works for IP addresses. As I said, the RIRs have all implemented it, and obviously it works for IPv4 and IPv6 addresses. It works for autonomous substance numbers, so. Yes, there's a lot of RDAP clients. There's ICANN, we have one implementation ourselves that is written in Rust. It is in Homebrew and some other, you can just download it with your distribution. But there's other implementations, NIC-info, OpenRDAP. So there's a number of implementations. Yes. There is still work ongoing for RDAP, extensions for different stuff. There's a IETF working group called regext, the Registry Extension Working Group. So, yes, and so there's some work going on for, so this is a finding about IP addresses. There's in RDAP you can actually make very complex searches, and but these are usually then we have for the RPKI there's work ongoing. So there's yes. So in summary, RDAP is a 10-year-old standard. It's not really new. It's used by GTLDs and CCTLDs, by RIRs. Yes. So RDAP in action. Let's see what we can do. So there's we have a website. You can go look up .icann.org. You can just they will make RDAP lookups for you, and then you get all the domain information, whatever you can get from there, and it will display it to you on a web page. Unsurprisingly, but so if you do that with a command line client, It's you do the exact same thing that you do with the WHOIS client today. Today you write in WHOIS ICANN.org, and now you write RDAP ICANN.org, and then our own client will display the stuff to you in this little table format, you know. And yes, but in reality, you get a blob of JSON code, right? And then the client does some massaging of the data and shows it to you in a more consumable way. But it also means that you can do some scripting with it. So here I done a little JQ filtering, and see, I get out that the CSC is the registrar that ICANN uses. Well, so we actually made some research into RDAP performances, you know, because obviously this important to people that, you know, stuff doesn't get slower on the internet. And what we see is, you know, that it's, RDAP queries are, well, most queries are quite fast, but then there is some RDAP servers out there that are really, really slow. You know, a query that takes several minutes, that's, you know, I think we all would think that has failed. Yes, and we looked at it, there's something that says, you know, does the response size have anything to do with the response time? But it doesn't. It's just, you know, there's, you know, no connection between these two, and we can see that, you know, the variation in IPv4 answers is a little bit larger than in IPv6 answers, but, you know, it's still equally fast. So, you know, not a big problem. We even for ASNs and domain names, there's no real, you know, it's so RDAP deployment is well, as I said, the generic top-level domains all have to do it, so they all have an RDAP server. There's nothing to, you know, look at. There's 100%, but then we have obviously the country code top-level domains. I mean, the RRs also have it all, so, you know, no statistic there, or just a very boring one. But for the country code top-level domains, it's a little bit more interesting. And as you can see, there is already some that have done it, but there is a lot of space for improvement. Let's put it that way. And yes, so we have actually statistics. So all the generic top-level domains have to report to us how many queries they get for WHOIS and for RDAP. And as you can see, since something last year, the RDAP, obviously, when, you know, people started to switch over switch off their WHOIS servers, people started to switch over to RDAP queries. And as you can see now, we see a lot more RDAP queries than we see WHOIS queries. Yes, so the Walking Dead protocol, WHOIS is dead, long live RDAP, and I hope I have convinced you to switch over your command line to an RDAP client. Good. With that, I hope you have questions.
So, any question for Ulrich? Really? No? Okay. One? Okay.
Vlatko, Marlink Cyber. One question regarding abuse. So you would recommend now to use RDAP for abuse contacts, finding abuse contacts?
Yes. Yeah, for all the generic top-level domains, absolutely. And then for IP addresses, obviously, if you already start using it, use it for IP addresses too, because all the RRs have implemented it. So it's much easier to, you know, just use one. And for the country codes, it's a hit and miss. So it's, you know.
Hello.
Yeah.
That's it?
Yep.
Yeah.
Hi. Daniele Arena, Namex. Maybe I missed it, but do you have a plan to I'm not saying force, but encourage CCTLDs to implement RDAP? And do you have an ETA or an idea of when that's going to be deployed?
So, no. So the answer is no. So this is, as ICANN, we have absolutely, the CCTLDs are absolutely independent of ICANN. So we can absolutely not tell them to do anything. We can suggest stuff. We can show them good examples. We can argue for that it might be a better way, but they do whatever they want, right? It's the same with DNSSEC. All the GTLDs are signed. We are working with the CCTLDs to get ours signed too. So it's yes. So we absolutely have a program to talk to them and try to convince them, but there's
There's no incentives that...
No, we have no incentives, and I think that it is by design that country code top-level domains are independent, because they should, it's like your country should decide what's the best for your country, right? So yeah, we don't have anything to tell them, but on the other hand, I think at one point WHOIS becomes irrelevant. I always say the day that .com will switch off their WHOIS servers, everybody else will talk to you and say, you need, it's just...
Okay, thanks.
Vladislav Vidikov now with the .mk CCTLD hat. We are a very small CCTV, and we try to incentive our dear 18 registers to actually switch all of their needs from WHOIS to RDAP. And it doesn't work, because they are not willing to invest the time and programming integration. So yes, for incentives, I always say that IANA will kick us out. Hopefully they don't understand that we're independent. So they have to do both DNSSEC and RDAP by the end of this year. But actually, since the carrot doesn't work, I would require from you, dear people in ICANN, to come in with a big stick to actually tell them how important this is. So even with a small registry, it doesn't help. We tried 3 times in trials, and they are panicking terribly. So we had to write our own wrapper who actually does most of the RDAP stuff in WHOIS land, just to complete the space until we try to make them work. So yes, we are independent, but that independence is usually the problem when you have to work with usually it's delegated to other entities, and they are only interested in the money concept, not in technology.
Didn't say it was easy to be a CCTLD,
That's it. Ulrich, thank you so much.
Thank you very much.
Thank you. So, to the space and the back. Our next speaker will not speak about the Artemis 2, but about satellite communication networks. Katarina Stefanović, the floor is yours.
Hello, everyone. Just to check. So, hello, everyone. I'm Katarina Stefanović, and I work in Telekom Serbia as radio access network optimization engineer, and I'm also RIPE Atlas ambassador, because in my free time I enjoy taking measurements and understand how internet really function. And so take your seats and fasten your seatbelt, because today I will take you to a journey to space and back. And we will talk about satellite networks and how we connect our entire planets. And does really internet performance rely on geography or on intra-domain routing policies? So agenda for today, we will talk about motivation behind satellite communication and where we today have connectivity gap. Then we will talk why global connectivity is not truly global. Then I will explain you low Earth orbit satellite architecture and why internet paths are different in this kind of architecture. Then I will explain you my measurements from RIPE Atlas platform and why I chose RIPE Atlas platform. Then we will talk about interoperability between non-terrestrial and terrestrial networks and how future connectivity will be. If we are just a tiny dot in the universe, as Carl Sagan said, because I like Carl Sagan, and does anyone here heard about Carl Sagan in a public? Oh, nice. So how do we manage to connect an entire planet? I think that satellites have played a huge role in this story. But even today, with many new technology, global connectivity is not truly global. Internet performance depends on routing decisions, not only on distance. And many parts of the world still lack infrastructure and connectivity, and I will show it on my next slide. According to the GSMA report, around 300 million people live outside mobile broadband. So even today, in 2026, global connectivity is still shaped by where infrastructure exists and where it doesn't. On this slide, you could see a map of mobile broadband coverage, and you could conclude that roughly 80% of Earth's surface lack reliable terrestrial coverage. But keep in mind that 70% are covered by oceans, where we don't have any infrastructure, and if we are on some boats inside of nowhere or inside of Pacific Ocean, we are far from any continent. We are far from terrain. For example, also, dense vegetation like Amazon rainforest, signal coverage is limited due to attenuation. Also in in remote terrain areas like mountains, Himalaya, we will have high deployment costs. And in low-density regions, like Iceland's, specifically in Asia-Pacific region, where we have around 70,000 islands, we have complex and fragmented areas, which as operator we need to cover. And if we want to use, for example, mobile infrastructure, let's say base station, we will have high cost and low return per user. So how do we solve this problem? How do we bridge this coverage gap? Let's say with satellite communication, and that's the motivation why we talk today about satellite networks. Low Earth orbit satellite network is a new connectivity layer today. Global coverage, they need global coverage without dense terrestrial infrastructure, and they are designed for remote areas, oceans, and low-density regions. They are just completing the terrestrial network, not replacing them. And now when we understand the motivation to do the research in satellite networks, let's talk about architecture of low Earth orbit satellites. They operate in a highly dynamic environment first, and they're orbiting in a low altitude below 1,000 kilometers and with a speed of 7 kilometers per second, which is highly dynamic. You agree with me. So that's the reason why when we compare GEO satellite with LEO satellite, we have lower latency, but at the cost of high mobility and constant handovers. Then let's talk about architecture. For example, we want to visit Netflix website. Our packet goes from our PC to user terminal, which is phased array antenna. then converts to a radio signal to Q and K band, which include really, really high frequency, as you could see in this tiny table. Then the packet goes to radio signal to a satellite. Then this information could either go to laser links to another satellite, or either could go to the ground gateway, which main rule is to connect satellites to terrestrial fiber networks. Then that information go to the point of presence, which is usually some data center, and main functions are peering and routing. And that's the point, an entity where our packet enter a global internet. And then our packet reach the target, which is, for example, Netflix server in Singapore. Then on this slide, you could see how many points of presence today we have of Starlink network we have around the world. And we could see that we don't have enough in Asia-Pacific region. And on this slide, I want to present some simulation. I also write down the link. And I located the user terminal, or let's say this phased array antenna, in Belgrade, here in Serbia. And these green areas show a field of view of my user terminal, or let's say how many satellites my user terminal could see. In this point of my measurements, it could see around 20 satellites. And choose this one, as you could see, 33646. And this satellite is connected to a ground gateway in Italy. As you could see, this orange dot. And this purple circle is satellite coverage area. And now I want to play a very interesting video, but you could see that one user can change multiple satellites. And if we have different satellites, we have different ground gateways. So this video represents how routing paths could change in just a few seconds. And then change to another satellite, gateways in Turkey. And then change to another satellite, but also change the gateway. Gateway now is in Poland. So is it interesting how the internet paths could change just in a few seconds? And these slides, it's here to visualize laser inter-satellite links in space. So we move our routing policies and our routing paths from ground to the space. Laser links keep traffic in space. And we also have two types of, let's say, connections between satellites, because they could now talk with each other. First one is intraplane, where satellites could talk with each other through optical links, or let's say through laser, in a same plane, and also interplane in a different plane and orbits. So low Earth orbit Starlink is not just a radio link, it's an Internet Autonomous System number. And then we talk about architecture and simulation, but we want to see real measurements and to see how we route our packets in Starlink, let's say satellite network, in a real condition, on real internet. And that's the reason why I chose RIPE Atlas, and why I think RIPE Atlas platform is suitable for global routing analysis, because I could see global end-to-end view. And I suppose that most of you from public know about RIPE Atlas platform, and that's the reason why I want to go into a detail. But if anyone have any question, or if we have any fellows who want to know more about RIPE Atlas platform, you could approach me on a coffee break. But let's say I chose RIPE Atlas platform because now, today, we have around, I think, more than 13,000 connected and stable probes all around the world through different radio access technology. And we could conduct so many measurements, and we could conduct and choose source and targets probes whenever we want on an Earth planet. And that's the reason why I think RIPE Atlas is a good platform. And you could see on this map RIPE Atlas controller, which is in, I suppose, in RIPE NCC. And the RIPE Atlas controller is the brain of this platform because they coordinated all these measurements and gave results to me as end user. So you can conduct, for example, ping and trace route measurements. Ping, where you measure the round trip time, and trace route, where you could see your routing paths. So architecture defines possible paths, but measurements reveal actual paths. So let's talk about my measurement methodology. First, I conducted same measurements on same measurement platform, which is RIPE Atlas, as I said. Then I selected same country where both access technology are available. I chose two different access technology. One is fixed wireless access network, which means that my RIPE Atlas probe is connected to an internet router, home internet router, which could be 4G or 5G, and also a Starlink router. Then I conducted the same measurements, ping, which means I measured the round trip time, and trace route, I want to analyze routing paths. Then I used TCP protocol in my trace route measurements because on port 80, because I want to avoid filtering and reflect better traffic conditions. And I perform my measurements every 100 minutes over an 8-day period. And I think for the first step, this is enough data to analyze. So the goal was not to optimize either network, but also to observe how internet routing behaves when only the access technology changes, while all other factors remain identical. Then, this is how my access technology looks like. On my left side, you could see fixed wireless access, which means that my RIPE Atlas probe is connected through LAN cable to a 4G or 5G router. And then that router, through radio link, is connected to a E node B or G node B, which means fixed base station, some outdoors. And we have mostly stable radio conditions with rare cell handovers. And because I chose different country from Europe, I will have multiple internet service providers with multiple ICANN environments. And then on my right side, you could see how LEO satellite router could seen, and I chose in my measurements, RIPE Atlas probe is connected also through LAN cable to Starlink router, and in low Earth orbit satellite networks, we have dynamic space segment in a space, and also we could change satellite and gateway in every few seconds, and we will have in this axis radio access part of network single global autonomous system number. And now, when we understand the difference between these two radio access technology, I want just to go through so many factors which could impact latency in a different radio access technology. In satellite communication, we could have frequent changes of satellites, beams, gateways, which could trigger handover between them. Also, we have propagation effects like weather, clouds, rain, solar and magnetic radiation, which could affect the signal. And also, congestion could decrease the latency, increase the latency and decrease the throughput. And in mobile communication, we have multiple layers which could increase the latency, like RAN and core part of the network. And also, we have constantly handovers because we have lower, let's say, radio conditions like fading interference, decoding errors, and beamforming fluctuation. And also in this type of network, we also have congestion per cell. which could also increase the latency and decrease the throughput. And I talk about my source probes. Now my target probe was in Singapore. And why I chose Singapore? Because it's in Asia, and I wanted to measure long paths, long intercontinental paths between two different continents. Also, this is a really stable destination, and it can expose routing inefficiency and detours. And also why I chose Singapore, because this is a major Asia-Pacific hub with stable connectivity. And then the results. On this graph, you could see average round-trip time and hop distribution. And on the first glance, you will think, and you might thought, that one radio access technology will outperform another access technology, but that's not the case. For example, in Austria, a fixed wireless access network has higher latency than satellite network. But in the UK, they have pretty same round-trip time. And also in Bulgaria, which is in sea region, you could see that hop count is not correlated to the round-trip time. Because, for example, in fixed wireless access network, we have 15 hops and really high latency. But in a satellite network, we have 26 hops and lower latency, which means these two is not correlated. And then we need to think if in one country, satellite communication is better than fixed wireless access, does we need to think about interoperability? Does future networks may benefit from combining terrestrial and non-terrestrial networks? And then I chose Bulgaria as a country to observe the routing paths and to show you my trace route, because now we are at Southeast Europe meeting, and Bulgaria is in sea region. And from this table, first you could see that fixed wireless access probe have higher latency than any of probes which are connected to the Starlink router in Bulgaria. And you also could see that fixed wireless access network have one fixed stable routing path during my measurements, but in Starlink, they are changing. So we have, let's say, dynamic routing paths. And when we include internet exchange point, the latency is much lower. So some key insights from these measurements: that hop count is not a reliable latency indicator, that routing path has a bigger impact on latency than access technology itself, then IXP play a key role in reducing latency by enabling direct interconnections. And maybe final message is routing architecture dominates access technology. And maybe the future of transcontinental routing hinges on broader intra-satellite links, integration, and stronger point of presence in Asia-Pacific region. And I have a privilege to measure the quality of service when I was on my flight from Doha to Jakarta on Qatar airplane. And you could see on this slide that download throughput is really, really good, around 200 megabits per second, and also in download, but in upload, 20 megabits per second. And I have one question which come into my mind is, what is the law and who control my traffic when I constantly change the country which my airplane is above? And I will make, let's say, a conclusion with some questions for you, because I'm also searching for answers. Is if performance depends on interconnection and routing, is radio technology truly the primary limiting factor? If LEO networks brings the edge closer to the users and create a new entry points into the backbone, are we witnessing a fundamental shift in how the internet is structured? And if satellite networks can route traffic through different countries, it even enters the public internet, who really controls the internet experience? The user's country or the network's point of entry? So if you have any opinion about these questions, please approach the mic. And for the last satellites, I would like to say space may be dark, but the future of satellite communication is bright, where connectivity will meet interoperability day and night. So thank you for your attention.
So, are there any questions for Katarina? Please approach the mic. Thank you.
Thank you for the piece of information, very interesting. I have one question. How do you think, will Serbia allow Starlink to get into the country someday?
What could you
Will Serbia government allow Starlink to make
Okay,
their
Serbia
service
here.
here? Yeah.
I think it's not available for now, but in the future, I think it will be available as a service. So,
Thank you.
Okay, thank you so much. Thank you, Katarina.